How you doing? I'm just trying. It's difficult doing this with one screen. It's like, whoa. Right. I think that's fine. I think I need to see that in there. Put that on there. And I can put this one here. And then I just need to get the old chat going so I can see you guys. We've got the chat going. So last time, and then I can go on that. Right, so we've got that going. Yeah, because I wasn't using Unity last time. This time I'm going to use Unity. And I think move this one up. Right, get rid of all this rubbish here. That feels a bit better. Let me know if that's okay. You can see everything. And if I click on here, I can probably get to see. Uh-oh. What happened? It'd be nice if I could get rid of that. Chat settings, show what icons, show moderation, app show messages. No, let's hold it. I'm all blurry. Right, yeah. There we go. So we should be good. I'm just going to check. Yeah, we are. Good. Thanks, Music Links. How you doing? Good to see you. Yeah, dark mode. Absolutely. I always program with dark mode. So I'm just what I want to do is work with Unity today. You're kind of cramped. Yeah, I'm okay. I think we're all good here. So first thing we're going to do is look at doing physics yourself. You know, it's like really simple physics. One of the problems with Unity is that it does everything for you, and so what this means is that everybody does things in the same way, first of all, which is not necessarily good. It means that people don't train themselves. It means that people are distanced from the mathematics. It's a bit like, you know, trying to, if the whole point of, is it programming? You could even say game development, you could almost even say anything. It's got to be about the journey. I mean, you don't make video games just so that at the end you have a video game, and that was the point of making a video game, is to have a video game. Because if you want to just have a video game, you can just go to a shop and buy, or go online and buy a video game. You can just buy it, and then you have the game, and then you don't need to go through all the effort of making the game. So your motivation for making a video game must be to make a game that doesn't exist, yes, but really the real motivation for making a game, or in fact doing anything, is to do it to others. You know, the reward for a thing done well is to have done it. You know, so Emerson. So then that's the shame. So what's one of those things about Unity, which is Unity's great, right? But it's like if people like running, and running is the hobby, is running, and is then everybody is going to get a piece of middleware known as cars to help with their running. It sounds a bit silly, but it isn't really. My point is that part of the whole thing is that you train yourself. And that's the thing with mathematics. It's actually really good for you mentally. And it should be, you know, if you haven't been made to be terrified of it, it's actually fun. But you get something like Unity, and you just bypass it all. If I want to make a bouncing ball, you know, I can just go into Unity and say, let's make a quad. I didn't want a quad actually. What I want was a plane. Let's make a plane. Boom, there's a plane. And then you go, and it's a pretty bright plane, isn't it? So I'm going to go and create a material and just make it a little darker. Just, so I can call this grey. Oops, thank you. So this is going to be a grey material on there. Boom, okay, so it's not so bad. So, and I'm actually going to try to hide this game window every time I hit play. Let's go to just do it anyway. There we are. Alright, so I made myself a flame, right, and then, oh, over here we've got these things that are always there, like in your face, and annoying. So I find that just reduce their size down to 0 works quite well. Okay. Then we're going to make you know, I want to make a bouncing ball, so let's give ourselves a sphere, which was invisible because it was underneath the plane. We're going to put the plane at 0, which it is at 0, and the ball is 3.81 meters high. Okay, that's fine. And then what I want to do is I want a bouncing ball, so I'm going to do the maths. You know, just do this manually later, but just going to set up mine as well. I'll set it up the way you do it in Unity. Still at this point, just following a sequence of steps and not really thinking. Yeah, I want a plane, I've got a ball. Now you go and say, if you're not familiar with Unity, I want to make this physics object. How do I do that? Or you go into component, add. No, you don't. You go component physics, rigid body, and then down in here on this thing, as your hand begins to right, here we go. Yeah, just close all that down a bit, and here we have the rigid body. So this thing is going to be a mass of 1, and then there's these things like drag and angular drag, and what are they? If you don't know, well, the thing is, you can do the majority of this with like a couple of lines of code, at least in simplified form. And very often, that simplified form is all that you actually need. But anyway, we're going to go with this is the way we do it, isn't it? So we've got the gravity here. Now I hit play. And then, of course, when I hit play, I have to wait. Eventually, it comes off. Now, it's really weird, this, because you look at that and you say, what's going on? I mean, because that doesn't look like it's falling, does it? Let's be honest. It looks like it was just, you know, if you remember last time, I was showing you the graph of ballistic motion, and you're going to know it, you know. The longer something falls, the faster it goes. You expect it to accelerate. Look at that. I mean, that really doesn't look like an acceleration. And I've had this issue Yeah, it looks like it's being lowered, doesn't it? So here's the first. So there are a number of caveats here, because I know I can come across as a bit of or something rather, but I mean seriously, if we're talking about understanding of things, anybody who's gone and done this, who's followed the instructions to do this on any of the tutorials, you look at that, and now that is dangerous because that is wrong. That was not a fall. It was the first thing I noticed when I started using Unity, like back in 2010. Why? So I'm a little bit off topic, but not that much, because I mean, here we are again. Now this is a 2019 version that's doing it. What could be the cause of this? Right? Because I mean, yeah, let's think about it. Let's talk about it. I mean, like, you've got your at least your level is links. So what do you think it could be? This is all good for, this is still mathematics because it's giving you a context for the mathematics. I remember thinking exactly this. That doesn't feel right. It's just like it's. I mean, it doesn't look like something being dropped. No ideas? Well. I like you to think about it. I actually don't know 100%, but there is a trick. There is something we can try. We can try as an experiment. I have a theory. I never really sat down to study the theory in detail. And actually, the theory is wrong. If my theory was correct, maybe there's two things going on. Hey, Peter, how you doing? Will Watley, how you doing? I just realised there could be a reason. The reason could be because I have perspective. And from the way that I'm looking, in fact, if you watch an object fall away from you, I'm good at things. If you watch an object fall away from you without air friction, you just sort of watch it sort of disappear. It won't actually disappear like zzz. It actually shrinks at a constant rate. And the reason it shrinks at a constant rate, even though it's accelerating very fast, is because for it to shrink, it needs to actually move a long distance away. So it's I'm wondering now whether that's the effect. So what I'm going to do is just flip this around, put this into isometric view, which is kind of good because then we can be sure that there isn't any perspective. And so that's kind of like 2D. It still looks wrong. Okay, and how are we going to figure this out? We're going to figure this out with mathematics. This is Unity's physics engine, after all, and I'm asking Unity's physics engine to simulate the falling of an object. So, one thing, this was my theory as to the problem, was that when you hit play, it actually takes a little while before the thing kicks in, doesn't it? And I thought it was to do with the delta time. It could also be to do with scale, admittedly. This is quite big. It's a big ball, isn't it? In fact, if you change the scale, so if I make a really huge ball and it's going to fall at 9.8 meters per second, but to get a good view, I have to pull myself back, I pull the camera back. What you get is, objectively, at least on the screen, you're going to get a seem like gravity is less. I mean, if I'm looking at that and I say to you, that ball is a marble, and I do this, you go. And I think actually this is probably close to the issue. Well, no, it's a bit more complicated. Yeah, it's not really. Well, maybe it is. So if I said this is a little marble, you'd say, well, what's this on? A planet with very low gravity. But it's because it's a very big ball of 1 meter. I'll tell you what I'm going to try to do. I think it's more than one, because that thing that I said about the startup is also true. Oh, it's not a Unity thing. It's to do with perspective. There's also to do another thing that's a complication. Well, oh, and it fell through. Oh, it fell through. It fell through the floor. It's like not supposed to do that. Oh, what is it with this? Well, of course, these are the things that you are faced with the first time you try to use Unity physics. Yes, you go, I went through the floor, I'll show you how you do that. Yes, exactly. Hey, known childrox. Exactly. That's something I will come back to in a minute. In fact, there's a bunch of things going on. One of them is the scale. The second one is that at the startup time, at the beginning, it loses frames because it's starting up. It stalls as it's loading shit in and all the rest of it. And that causes a big delta. And so this means that the object actually doesn't start falling. You would see it fall. There's no doubt about it. If the thing starts at a stationary position, right when you start the thing off, you should see it sort of accelerate. Even with scale, you should see that acceleration. You don't, because the beginning of the animation is cut off because Unity's been starting up. So that's one thing. A second thing that happened here is that the question of scale. That you know, because this is quite a big ball, it means that in effect gravity is less or seems less. So this is, if you've ever watched things like Thunderbirds, where they made all these big explosions with models, what they did was they filmed it at a high speed and then played actually slowly. By slowing time down, you actually can make it look like your tiny model is really big. It's quite a cool trick. That's how they did it. Because you look at it and they blow things. It's brilliant. They blow things up and But in reality, that explosion with a little model was something like. It's like, okay, yeah, because it's small. But if you then film that really fast and then play it back like at 1/10 of the speed, then instead of you get. And then if you put the camera in and then make the thing take up the whole screen, then you get the illusion that the whole scene is massive. So that's the second point, has to do with scale. And the third point has to do with, oh well, I'm just trying to pick this up. And sometimes like that. Look, I pick it up, there we go, and I drag it up, and it's like, what the problem is that as I drag it up, it's already built up a velocity, so I'm dragging the thing up, the velocity is increasing. When I let go, it just falls immediately. That's it. Wow. So the first thing I'm going to do right now is let's get some scaling, because this is a meter radius. So I think it's 2 meter. No, it's 0.5. It's a 1 meter sphere. That's quite big. If I make it the size of a football, I'm going to transform here, and I didn't have to look that up. And now, this is the size of a football. So having done that, and now I zoom in, we should get the gravity. Well, let's see. There's the old thing. So there, I edited in play mode. Yeah, still right. Preferences, colors, play mode, tint. Do not edit. Right. Okay, let's try that again. 0.11, 0.11, 0.11. There we go. And I hit play, and it's gone through the floor. All I wanted was a bouncing ball. play mode tilt is it's just it's too gnarly even for me. Let's try something a little more reasonable. Well, at least it's green. So yes. Well, one thing at a time. Let's bring this closer to the ground, which I've got there, right? And then I hit play, and yeah, that time it actually stopped. Although it didn't bounce, did it? It's not very. We need to deal with it. But you see, look, it's like it's not very satisfying. You see how it just immediately is falling. So, what do we do? Well, one thing we could do is turn gravity off. Then we turn gravity on. And now it's actually beginning to look a little bit more like it should. Still a little bit jittery, but it's better. If I turn gravity on, let's look at from the sides. We've got no perspective. Remember, perspective could also be an issue. And we turn this on. Oh, that was quite good. So I'm going to take this football and it fell through the floor again. I'm going to take this here and hit play, and then we'll turn on gravity. Okay, that actually looks like now there's some gravity, but it won't happen if I just do use gravity on here, because then it just, as you can see, the beginning of the animation is cropped out. That's really annoying. I mean, I really find that hugely annoying. So what we're going to do is I'm going to create an object, a C# script, which is, what I'm going to do is I'm going to call it whatever. I mean, it doesn't really have a very class whatever. And I've got some little shortcuts for just changing the. Oh, that didn't work. Oh yeah, that's good. Come on. Right. Anyway, right. So what I'm going to do is do this, and I want, after a certain amount of time, I want it to turn gravity on. So I may show another time a trick here to get around all of this pain, but for now, we'll do rigid body. I'll put the keyword new in here, so it won't complain about the fact there really is a rigid body. And on the awake function in here, I'm going to say rigid body equals get. Sorry, I don't have a project in here, so the complete doesn't work with them. Get component rigid body. Okay. Now, after a certain amount of time, I want to turn gravity on. So, of course, I could do things like invoke. You know, you'll see this. I could do turn on gravity. I hardly ever use invoke. I think it's really awful, actually. But but let's use it for now. Because you have to pass in a flipping by name. I mean, I would use a string to access. Maybe there is a way of. Maybe you'll also take it the other way. But let's call turn on gravity after 2 seconds. The Unity should be able to start up in that time. And then we'll sort of do rigid body, dot use gravity equal true. So what should happen now is if I attach my script known as whatever, and I attach that to my sphere, like so, you can see it there, and then the sphere has gravity turned off, and then I hit play. So that's good. I think Unity's starting up fairly fast. Now I'll reduce that to 1 second. So now actually you can see it actually start to fall. Okay, that's better. But the problem is that my brain has already been frazzled by what I had just witnessed. So it never quite feels as like this. I suppose it's kind of like a developer's version of motion sickness or something. I no idea. Anyway, but I really don't like using invoke, so I will do something else instead. No, I'll leave that for another time. It works usually. We can always find out why invoke is not really that great. Anyway, let's put preferences, adjust the play mode tint a little. So the problem is, of course, it's going through the floor. Now you might remember last time I said to you, showing you how to do the motion of the ball, and then that was talking about collision detection with the ground. The problem here is that, well, we can probably see it if I hit play. Actually, you should be able to hardly ever use the step-by-step function. Oh, I have to go through the pause. Yeah, that's why I hardly ever use the step-by-step function. Okay, right, here we go. Well, let's look at this from this point of view. There we go. Yes, and as you can see, because every step it's teleporting really per frame, and that's quite a jump that's going per frame, even at that speed, and it basically just teleports in effect through the wall. You'd think, why doesn't the engine pick up on that? Well, it sort of can, because it doesn't always work. But over here on this collision detection thing, oh, you might be wondering, how does it know where this is? It's because automatically that you create any object, it automatically makes colliders for you. So there is a collider for this. And the collider is a mesh collider, which is terribly inefficient. But this mesh collider is very thin. So this is jumping through it. And what you can do is go to your sphere and you can turn on, and of course you've got tons of options here. You can go continuous dynamic, and continuous speculative. And it's basically to do with optimization and robustness. And I read documentation on these from time to time and then generally disregard it, because my experiences with the physics engine in Unity is that it tells you the way that you should behave, and then you dutifully take that information in and then observe how it behaves in a different way. So you might as well just play with it. Oh, that was discrete. Let's try continuous. That worked. I'm just curious. Let's try continuous dynamic. Let's try continuous speculative. So I'm just going to put it on continuous on the basis that's probably the simplest of them. Bounce. It's not bouncing. Why not? Well, it's not bouncing because I need to have a physics material. Physics material. I'm going to call this bounce, because by default, although Unity by default does provide a default value of friction, two kinds, dynamic and static, the bounciness is called the coefficient of elasticity. It actually has a technical term, because we are technical people. So, you know, we're kind of technical, grown-up people. We can call it coefficient of restitution or coefficient of elasticity. I suppose it's a bit long. Bounciness. Anyway, let's set the bounciness. The bounciness value probably goes between 0 and 1. I was checking it wasn't a percentage. It's 0 and 1. So Udity's trusting that you know how to use, decimal numbers. I'm dripping a bit of sarcasm here. It's all right. It's because, you know, after 10 years of a love-hate relationship with Unity, you know, survival, your mental survival does depend on having a few barbs ready just to fight back a little bit from time to time, you know. So what I'm going to do is set the bounciness of this to 0.8, and then further complication is that you friction and bounce combine because you have two surfaces. Is it going to average the two surfaces, or is it going to use the minimum or the maximum? Or so what I'm going to do is just avoid all of that rubbish by simply saying that the ball will have this physic material on it, and so will the plane. And then I don't really need to worry. It's the same material. So if I change this on one, it'll change it for both. All right, let's have a look. That was going really well, wasn't it? It was it was going so well. I've been here before. You know, you're looking at it, you're thinking, that is bouncing, that's what I wanted. I want the bouncing ball. Dum, 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 dum. What happens? So, what it has to do with this one is the settings of the physics. You see, engine. Because the physics engine defaults, hey FME, how you doing? The physics engine defaults are all designed for one thing only, ragdoll physics in a first-person shooter. This is because most video game engines that have ever been created have as their first focus first-person shooters, and then when people have physics in their heads and they combine physics plus first-person shooter. This is mathematics. I did promise you a mathematics class. Physics plus first-person shooter equals ragdoll. There's so much more. No, right. So why? Because it means that the engine is optimized for not only ragdoll physics, but also which means dealing with objects which are quite big and a ball is quite small. I mean, it's only about the size of a football, right? So it's optimized for large objects and also a lot of them, like, you know, because it's no good if you've just got, like, you know, 10 ragdolls, 50 ragdolls. When they demonstrate these things, you know, you've got to have 500,000 ragdoll balls at the same time. And so what this means is the default settings in Unity basically are rubbish for anything other than a demonstration of how many thousands of ragdolls you can have at the same time. So what we need to do, if I'm dripping sarcasm too much, you will let me know, won't you? I only had one beer. But the thing is, I had some good news this week. Was it last week? It was actually last week. That's kind of led over to this week, and there will be news soon. And in this climate, you know, good news, you kind of need it from time to time. So, anyway, back on topic. So why does it do that? It's because, as I said, it doesn't care about accuracy. This is obviously not very accurate. I'm just trying to remember while I'm talking there what the option is. And it's not, most of the physics things actually have different options. Unfortunately, this one might, I think you can change it by object, if I remember rightly. But let's go to the preferences and no, the project settings. Project settings, where are you? There we are. And we're going to go to physics. And then you can see a whole bunch of global settings. Oh, there is a default material. I hadn't noticed that before. Well, yeah, I don't know why I never noticed there was a default material. So that's kind of useful. I should remember that. Bounce threshold. Oh, that's the one. It's the bounce threshold. Let's have a look. I'll hover over it. A contact with a relative velocity below this will not bounce. So I would like you all to think about this a moment. This is still maths for games. Because you say, what's wrong with that? This is a bounce threshold of 2, which means that anything going slower than 2 meters per second won't bounce. Hello? 2 meters per second is not exactly, slow. I mean, I imagine it works very well if all you're doing is demonstrating ragdoll physics. Nobody really cares that that was a bit sticky. I know, but I guess anyway. So you know what? Let's put the bounce threshold to 0, and we'll try this again. And hopefully, now, after all of that, we'll have. Come on, you can do it. You know you want to. What's it doing? It's sitting there jittering. Oh, come on. Can I get rid of the jitter? Yeah, but I don't like it. I know music links. It's like, I don't. It shouldn't be necessary. Well, yeah, maybe it is. Well, of course, I have ways. Well, I'm kind of playing in my mind as how much can I moan about that justifiably? That's basically my question. I've just realised I'm exerting far too much mental energy on answering that question that probably isn't that important. So what I'm going to do instead is go and try the very scientific process of let's make it not quite 0. My God. So, in fact, that is a speed of 1. So this is pretty rough, frankly. I'm going to go to, that was 1 centimetre. I'm going to go to per second. Well, let's go to 10 centimetres per second then. Yeah, that's a 10. All right. So, I'm tuning. I tend to go 10 times. I either go 10 times or double. I'm going 10 times here. Bloody rare, it was 2 meters per second before. 1 meter per second is quite fast. Oh, but okay, that's too much. That just ended up with just a plop at the end. I mean, that was very unsatisfying. So let's one tuning. Let's go for 0.5. No, 0.5. And now I'm halving. Oh, this one is a maths workshop. It probably doesn't say that. but I'm just setting context at the moment. Look at that, 0.5, and it's still bouncing. So, you know, so basically, I can't actually have a nice bouncing ball. Maybe I could, maybe, you know what? Let's try that 0.1. And what I'm going to do is go to my sphere and go for continuous speculative. So basically what we have, that didn't help. So what we basically have is a situation where there is no actual, I can't actually use the Unity physics engine to make a bouncing ball that's pleasant. Because for it to be pleasant, it would need to stop its bounce properly. So at some point then you would have to use, look at that. Yeah. You know, so is to write your own engine in C. What do we learn from this? We learn this is why they put the bounce threshold where they put it. There is a second setting, but I've just seen that probably will help as well. So I'm not quite given up yet. But basically, in a minute, what I'm going to do is take you through how you can make a ball, you actually make the ball bounce by hand instead of using the Unity physics engine, but by using maths. You know, but I know there is a secondary thing about what I'm showing here, which is that for people who are not so familiar with Unity, it's also covering a little bit of a workshop in Unity, I guess, so that's why I'm going with it. But if I put the bounce threshold to point, oh, and there's a third part as well, that's introducing different kinds of elements to the physics, you know, to what physics engines do, which is kind of important for context as well. So this is the bounce threshold. I'm going to just try at 0.1 meters per second. So slower than that speed it will stick. But I did also see there is a default contact offset. Now this one specifies the distance which the collision detection system uses to generate collision contacts. If it's too close to zero, can cause jitter. Well, so I wonder what would happen if I put this, make this higher. It just doesn't seem to do anything, does it? But I think that, oh, it won't let, the contact can't be, oh, it can be smaller than 1. Just, it doesn't like being 0. No. So there you go. So, if you use the Unity physics engine to try and make a bouncing ball, you're not going to have very good or happy result from it. And it's really because it's not what it was designed for. So at this point, what you do is you ditch it, and you say, rigid body, be gone. Oh, but before I do, might look at this drag thing, because that's something we'll come back to. So as the thing falls, yeah, if I put the drag on, the drag is basically air friction. If I put a value of 1 in there, this is another way of potentially smoothing out the bounce, is that you can just provide air friction, which sort of takes energy out of the system. You can see there, even there. Jitter, jitter, jitter. Okay, so then we say, be gone. And the gravity of the situation has, you know, diminished. And missing component, there's no rigid body attached. Yeah, that's, you know why? It's because I'm still trying to run my turn on gravity hacky script thing, which I'm also going to remove after I've changed the preferences to get. I still think that's a bit too much. Okay, that'll do. So what I'm going to do is remove my whatever script, and so we'll actually start with some mathematics now. Yes, because there it is. So the first thing, because I want to make it sort of bounce nicely. So what we're going to do is, actually I can just carry on using whatever script and just edit it. I don't know if it's silly. So let's put there, whatever script, and then I can just edit it. So you don't need that anymore, and we don't need the rigid body. The only purpose of the rigid body is to have a velocity and angular velocity and all that kind of stuff. So I'm going to add here I'm going to add here a vector 3 velocity. This is going to be my velocity for my object, and we don't need any of that. I think we still could end up with the startup problem, but if we do, we'll come back to it. Now, everybody's familiar with this. This is the Unity's update function. Now, one of the problems with the Unity, well, it's not just Unity, it's all engines. Is that you've got this issue, right, which is that the update can happen at different times depending on how loaded your computer is, but you need the physics to execute on a fixed frame rate. So Unity provides these two, and if we use this one, whatever we do will depend on the frame rate. If we use this one, it won't. But there is a wrinkle in this, which is that if you want to get smooth motion, if this isn't executed the same number of times per second as this, then you will get a jitter in the movement. I know I've got rid of my rigid body, but there is an interpolation option, which will say interpolate. And what that does is it predicts where the object will be at any intermediate rendering frame. And so it gets rid of the jitter. So with the caveat that this can also be dealt with, but I'm not dealing with it right now. I'm just going to keep things simple. But I'm going to use the fixed update. And I think so that we can play with it, we might as well also make these public. So vector 3 gravity as well. Okay, so that's fine. If I save this and then hit play, now we can see, we hit play, we can see these two vectors here, the velocity and gravity vectors. What we're going to do on the update is I don't have enough project loaded for the Emacs auto to complete to work. Transform. I actually prefer not using IntelliSense, but that's a discussion for another time. So transform position plus equal velocity. Right, on the fixed update. Let's see what happens here. Now I'm going to put a very small velocity, 0.001. So what should be happening is this position should be changing. It's not playing though. That's all. No, we put play on, and there it is. It's actually adding a little bit of position, which is dependent on this velocity. The units of this It's 0.002 meters per 50th of a second, because the default for this is 50 TPS, ticks per second, times per second. That's how often that gets called. So if I want to make it so that it's in meters per second, I would need to now multiply this by time dot fixed delta time. So now I'm going to move that 1 meter per second. So that's 1 meter per second. And I can move it downwards also at 1 meter per second. You see there at the beginning, there's that stutter. You don't get smooth movement from the beginning, there's a jump. And that's that jump that we had before. So I'm going to actually deal with that in a really cheesy way here. If time since level load is greater than 1 second, then we're going to execute this. It's a very simple little thing you can do, which, there we go. And of course it's going through, I don't have any collision detection. I also do not have gravity. What I'm going to do is add a very simple form of collision detection. Now, for that, I'm going to do public float collision height, and I happen to know that this is point, right. Collision height will be half of that. Why don't I see collision height? Oh, I didn't save it. No, save it. Collision height, please. Here's the thing that I don't know if you know, but at some point Unity did this. You can do 0.11 divided by 2. You actually execute expressions in there. I found that one day and said, oh, that's actually quite useful. So if I do this, then I've got a collision height, and then I'm going to go and say here, just transform. You know what? I'm tired of typing transform every time. Public vector 3 position get transform position return. And now, just with that little trick, I don't need to say transform dot position every bloody time. I can just say position. If position is now less than collision height, log an error. I have a button. Let's just say log error. Right. I have error pause. Oh, and in fact I have a compile error. So what's wrong with this? Whatever position cannot be assigned to. Yes, you are right, because I also need a setter for it. Transform dot position equal value. One of the reasons for not using IntelliSense is that you can get better at typing. Well, it's true. Position less than collision height. That's wrong, because it needs to be the y. So it's the y coordinate of the position of the ball compared with the collision height. And I haven't got my automatic play thing in this project. Look at that. It stopped. It's like you have collided with the ground. Except, as we know, there is a problem with this. It's actually collided with the ground. It's a little bit below the ground, but we're not going to worry about that just yet. We'll just be happy that it's actually. And the great thing is I know exactly what's going on. There's no mystery, no zillions of parameters. It's all totally under my control right now. I'm going to make it bounce. So, okay, how do we make it bounce? Well, what I can do is reverse the y coordinate of the y axis of velocity, the y component, that's the word I was looking for. So you can do velocity dot y times equal -1 will do the trick. I multiply the y by -1 and you should bounce. Boing. That's quite satisfying. Now it's not moving at the moment with any kind of realistic ballistic motion. This might be a good time to tell you the story of a student whose name was, no, I'm not going to say that name. That didn't stop me from saying mine. But it was, yeah, look at my eye twitching. So, yeah, I once had this assignment, for students, which is to just do this basically, in Simple 2D. And the student decided that it was totally appropriate to use a sine wave to represent the motion of the ball. Please don't do that. Anyway, as you can see here, this is also not the correct motion. No gravity. You kind of want to see the gravity happening, but it isn't. So, what do we need to do to create the gravity? Well, velocity is a change in position. So, every frame we add a bit of velocity to position. This is called integration, and this is integration step, an integration step. So, integrate, if we use mathematical language, integrate velocity over time. And there is an initial position in the C, so there is an initial position, or a P0, and then there's the velocity, and we add a bit of velocity every time. In fact, check the units. Velocity is meters per second, and time is seconds. So if you took meters divided by seconds, multiplied by seconds, you get meters. So you know that you can meaningfully add that to position. Now, this is great. Now I want to add gravity. So the beauty of it is that this only needs one line, and we've got gravity. All I need to do is go velocity dot y minus equals no gravity. Yeah, let's put that in the inspector as well. So we put that in this. We put that in the inspector. So I'm going to put plus then. Would make gravity be negative. Okay. That's it. Job done. And it's easily as good as unities at this point. Don't believe me? No, I wouldn't. Whatever, it doesn't contain a thing for gravity, but I just made it contain a thing for gravity. Gravity already contains a definition for gravity. Oh, because I made a vector, I didn't, yeah. Or then we can have gravity in multiple directions. So let's just do the velocity. I'm adding gravity to velocity. Well, gravity is a constant acceleration. Oh, wait a minute. It might be a good idea to do this though. So now let's check, as unit check. If I add meters per second to meters per second to meters per second, that's nonsense. But if I take meters per second, which is what acceleration is, and I multiply it by time, I get meters divided by seconds, multiplied by seconds. I just get meters per second. So that's good. Now I can add them. So gravity is now in meters per second per second. So I can just go in here and put minus 9.8, and I got it one, whatever, meters per second, and we should have gravity errors. What's the error now? I haven't saved it. Right, try again. This is already better than Unity's, isn't it? And it's on an infinite plane. It's probably what you want. This is not C. It's true. It's C sharp, but this is a maths workshop. How are you doing prompt game dev? I'm good. I'm glad. I'm also good. So look at that. This is already, this is, there's nothing messing around with anything, but just using the most base. Basically, it's 2 lines of code to actually do the movement. Oh, that is, what, are you basically programming only in C, or you're using C? So, all right, well, but now you say, what about that test? It does bounce too high, yeah. At the moment, it's doing a, oh, that's awesome. At the moment, it's doing 100% bounce. And it's also wandering off. So I'm going to just get rid of the wandering off a minute. I will turn off the X velocity, and then here we go. This is one of the other things, is you try and do this with Unity. Make the thing bounce, and it's stable. You just try, so that it doesn't increase in height, it doesn't reduce in height, and oh, this is getting higher every time. So this is all relevant, especially if I do some calculus workshop at some point. Why is it getting slowly higher and higher? I remember the first time I considered these questions was when I was at uni, so 2021, programming on the BBC Micro, trying to make a bouncy ball. I was in the computer lab. I like that computer lab. They had all these terminals, DEC terminals, and BT100 terminals in there, and they had a BBC Micro in the corner. And the thing about the BBC Micro is that you could program the sound chip for it, so that when the bell rang, you could make it play a sound. So I programmed the BBC. I just did the BBC Micro so that the bell sound would be a very sharp ping. Everybody heard it in the room. It became a talking point. Yeah. So I remember playing on the BBC Micro, doing this very bouncy thing. Gravity gets added to velocity, and so it should, because if I don't do that, then you won't get the ballistic motion. So what I'm going to do is try swapping these two. I know the answer, but I want you to think. If I change that, I just swap the two. So the first time I took the position, the velocity, I added gravity to velocity, and then I added velocity to position. And then what I got is that it was getting higher and higher and higher. Now I've swapped the two, and now it gets lower and lower and lower. Oh, and now it's actually penetrated the ground, and it's sitting there every frame, reversing its velocity, and it's sad. It doesn't bounce off the ground, it's true. It bounces off near the ground, but that isn't the whole story. there is also, because that may be true, but it doesn't quite explain why. If I flip these around, one gains energy and one loses energy. And it is an order of operations problem, and it's because the order of operations, there's no way around it. This is known as a name. Euler integrator is the easiest kind of integrator, the standard integrator. And the problem is that the order matters unless the time step was 0. In other words, as you get your time step smaller and smaller, this difference, the order of operations makes less of a difference. And you can think about that, it makes sense, right? Because I am not here doing proper integration. I'm not integrating the change, I'm just integrating in steps, so I'm not actually taking into account how velocity changes over the time between the two steps, and this creates an error. Oh, well, you can try that, but that doesn't work either. I mean, it was exactly the thoughts I remember going through when I was doing this originally. I accept your point. So I think the point there that Grumpy Game Dev is saying, well, in fact, what we could do, we could try the following. We could say, this is demonstrating the limitation of stepwise integration, because we're integrating in steps. So what I could do is say the velocity plus equal gravity at the position equal the original velocity. So we could try that. So vector 3, just this v is going to be the velocity, and so, and then I use v instead. So as you can see now, I keep the old velocity, I change the velocity, but the position I apply the original velocity. But that's just the same as swapping. That is no different than than just swapping the two lines. I don't see any difference between the two. So well, let's try and see what happens if I edit the settings, the project settings, and we go to physics, which we have here. We can change time. We can change the fixed time step as 0.02 currently, or 1/50th of a second. Let's go to a tenth of a second. 1 divided by 10, 0.1. Tenth of a second. Okay. Let's see what happens. It's a disaster. Let's swap these two around. So we do position first and we try again. It's even worse. Look at that. So this is demonstrating something. That behavior is different, which means that the behavior of my integrator depends on the frame rate, which is why you don't use a delta time if you know what's good for you with this kind of thing. It's perfectly fine to use it where there aren't consequences, but in a physics engine there really are consequences, and this is the reason why you have a fixed update function, because you really want your gameplay, you want your game to play the same no matter what the frame rate is. I really hate the idea of a game that plays differently depending on frame rate. So anyway, let's try something else here. What I'm going to do is go to the preferences, project settings again. Go to project settings again, and I'm going to put my fixed time step to 1,000th. So fixed update will now get called 1,000 times a second. Let's see what happens. Except it didn't, probably because I changed it while it was in play mode. Oh, Unity, you make me nutty. You nutty. Unity crash on me like 4 times today. It's been very good of late, but today it crashed 4 times on me. Okay. So this is 1,000. It looks nice, doesn't it? Yes, you could, and that is the name of that integrator. It has a name, midpoint method, I think. And so what you're trying to do there is at least you might be able to compensate for it a bit, but it's still an approximation. It's just a bit better. Exactly. So I think we can look at this and say, well, is this good though? 1,000 frames per second. I mean, surely it's going to be good, right? And you might think, oh yes, that's good. Oh, look at that. It's growing in size. How disappointing. One of the assignments I had was for students to experiment with this. See if you can make the bounce stable. Well, there is a way to make it stable, and I'm going to do that. Thing to think about here is that even though there is an inaccuracy compared to the actual path of the real ball due to the time step, you probably don't care too much in your game, or I don't care too much in this simulation at this time as to whether or not it's precisely the same. What I do want is I want to create that perfect bounce, something that you cannot do with a physics engine in Unity. Why would you want to create a perfect bounce? Well, there is opportunities for interesting gameplay that way. For example, you could make an enemy or an object or something that you have to interact with bounce with an infinite bounce. It's such an easy thing to do if you know how to do it. But if you've never thought about this and never done this, and you're just working with the Unity physics engine, you're going to get frustrated. This is why it's important to understand what's going on, to have some kind of basic understanding of mathematics and also physics and how the things work together in order to know. Otherwise, what you will get is all kinds of hacky workarounds just to try and make the thing bounce. And this is going back, as I said, a long, long time to 30, maybe 35 years. And that lesson I learned working on the BBC Micro with my goal of creating a bouncing ball has served me ever since, because it's the kind of thing that informs so much other work, and it was a great introduction to calculus in the end. The whole thing about integration, issues about making simulation stable and whatever else. So, what I did was, I was frustrated by this, if you imagine, on my BBC Micro. I wanted to make the bounce perfect, and I had this thought, and that was this. It might not be, but I didn't think in these terms back then because I wasn't sophisticated enough. But what I did remember thinking was, maybe it has to do with, the collision detection on the ground. And maybe I should experiment with how that collision detection works. And what I tried was this idea. When the collision occurs, I reverse the velocity. But how about I reset the position when I found this by experimentation mainly, and then sort of try to work out why it worked later. And I think you'll see why it's stable. I think I've got an explanation for that. So the position is before be able to compensate for it a bit, but it's still an approximation. It's just a bit better. Exactly. So I think we can look at this and say, well, is this good though? 1,000 frames per second. I mean, surely it's going to be good, right? And you might think, oh yes, that's good. Oh, look at that. It's growing in size. How disappointing. One of the assignments I had was for students to experiment with this. See if you can make the bounce stable. Well, there is a way to make it stable, and I'm going to do that. Thing to think about here is that even though there is an inaccuracy compared to the actual path of the real ball due to the time step, you probably don't care too much in your game, or I don't care too much in this simulation at this time as to whether or not it's precisely the same. What I do want is I want to create that perfect bounce, something that you cannot do with the physics engine in Unity. Why would you want to create a perfect bounce? Well, there is opportunities for interesting gameplay that way. For example, you could make an enemy or an object or something that you have to interact with bounce with an infinite bounce. It's such an easy thing to do if you know how to do it. But if you've never thought about this or never done this, and you're just working with the Unity physics engine, you're going to get frustrated. This is why it's important to understand what's going on, to have some kind of basic understanding of mathematics and also physics and how the things work together in order to know. Otherwise, what you will get is all kinds of hacky workarounds just to try and make the thing bounce. And this is going back, as I said, a long, long time to 30, maybe 35 years. And that lesson I learned working on the BBC Micro with my goal of creating a bouncing ball has served me ever since, because it's the kind of thing that informs so much other work and was a great introduction to calculus in the end. The whole thing about integration and issues about making simulation stable and whatever else. So, what I did was, I was frustrated by this, you can imagine, on my BBC Micro. I wanted to make the bounce perfect, and I had this thought, and that was this. It might not be, well, I didn't think in these terms back then because I wasn't sophisticated enough. But what I did remember thinking was, maybe it has to do with, the collision detection on the ground. And maybe I should experiment with how that collision detection works. And what I tried was this idea. When the collision occurs, I reverse the velocity. But how about I reset the position line? I found this by experimentation mainly, and then sort of tried to work out why it worked later. I think you'll see why it's stable. I think I've got an explanation for that. So the position is, before doing the integration, what I'm going to do, let's actually do vector 3, previous position equal position. So I'm making a copy of my previous position. Okay. Yes, actually, when you are doing, so this might have helped you with that situation. Actually, if you want stability, do the following. I'm not going to reset the whole vector because I don't want to disturb motion sort of along the ground, but for the y velocity, I can take the previous position dot y. And so what I'm doing is I'm flipping the velocity, but I'm resetting the position of the ball to the position it had before the collision. And so let me save that and then check my I might have already changed it, I can't remember. Ah, it's the wrong one. And then I get an error, and then I go to project settings, and yeah, this is still, let's put it back to 1/50th of 50 times a second, and this should be a vector 3, and I still have another error. Cannot modify the return value of whatever position. Oh, yeah, that's a more classic, isn't it? That's so irritating when you can't just assign to position because Unity won't, the API won't let you do that. So that's really annoying. So if you do vector 3, I usually write with right past this kind of thing. I'm going to vector 3 with p equal position, and then p dot y equal previous position dot y, and then position equal p. So all I'm doing is resetting the position of the thing. I've reset my frame rate, the fixed update rate, to 50 times a second. I'm going to hit play, and we'll see what happens. Oh, it's getting higher and higher. Oh, that is annoying. I shouldn't have done that, and now I've got to figure out why. Oh my god. There's this secondary highlight thing that Emacs does. Oh, that's it. There we go. Hi, Michael. How you doing? Good to see you. So what I've got to try to figure out now is why this didn't work, and we should. I'm just checking the code. Well, the first thing is that for the first 1 second I'm not. Okay, let's take that and we take this and have a little bugbear. So what's going on then is that it only executes the physics code after 1 second. I don't think that's enough of an explanation, but we can try. And here we go. Play, please. When you're ready. Right, it's getting higher and higher. So then I probably need to swap these two. The stream title. So really, what it should be with the stream, I didn't adjust the stream title, did I? Let me just, it's a bit late in the flipping day. Here we go. Edit. Live music title. Right now, live random jazz. Right now. Maths for programmers. Maths for game programmers. Okay. Cool. Also category. Oh, yeah. Yeah, you're right. Category. I always forget to sort of deal with that. Category. Category. It's like category. Math. Workshop. Done. Okay. Hopefully that's better. Hi, Bud. The velocity bar will be different in each bounce. Yes, it will, but that shouldn't matter. Arithmetic and maths, yes. Maths. Minus b plus minus the square root of b squared minus 4ac all over 2a. arithmetic. 1 plus 1 equals 2. And so now it's the order. And now that I've got the order the right way round, and I reset. So what I'm doing is I'm increasing the velocity first, then I'm adjusting the position, and then when there's a bounce, I reset the ball to be at the position that it was in. Ah, I see what you mean, Grumpy Dev. So when the bounce occurs, it just resets it to the position it had before. Now I'm just thinking about why. Because, okay, if you do the velocity, you add acceleration to velocity first, and then you add velocity to position, and then you check the collision. It feels like that's going to be more stable. And in fact, if that was the case where... Is that the case where it normally grows? Let me just check. I need to comment out the reset of the position. Yeah. So you can see it's getting lower and lower every time. And in fact, the reason, because there are a few things going on, the reason why it gets lower every time is because it's actually going through the ground every time on every bounce. And so, and this affects how much acceleration is applied. If I swap this around, I really don't have an intuition as to why 100% that works. Rather, I do for this bit, but not for why it doesn't work if you swap the velocity and the positions around. So I'm just going to leave that, since I don't know. Actually, I can't visualize it. I'd have to do a little, have to get out Desmos. But the second part of the reset I can explain, and that's what basically is happening is that you're allowing it to bounce at different heights. In fact, what you're doing when you do it like that is that it's as if the ground is uneven on each bounce. And by ensuring that the position is reset to where it was before the bounce, it basically means that the error that's generated by a different amount of acceleration that's applied to the velocity is removed, and it becomes as though you've got a ball with perfect coefficient of restitution, a perfect bounce, a bounce of 1. That every time it bounces on a different, slightly different height. But it doesn't matter that every bounce is on a slightly different height. It's consistent, doesn't lose any energy. If that makes sense, because that's what we're witnessing. So what we have here is it's totally stable. In fact, it is totally stable. It will not drift. I'm going to prove this by changing the frame rate. So we're going to go to project settings, and I'm going to go with, say, 5 frames per second. That's pretty harsh. 5 frames per second. Let's see. Now, I must point out that at 5 frames per second, it's not the same bounce that you will get at 50 frames per second or 1,000 frames per second. So it's still frame rate dependent. But if the frame rate is consistent, it doesn't lose any energy. You can just bounce around forever. Leave me now. So that's cool. We've actually got something that we cannot do in Unity. Unity definitely cannot handle that. Let's go and set project settings back to 150th, which is there. There we go, 150th, and boom. Now, I'm happy with that because that's nice and consistent. And there's something else I'm happy about. Because of the fact that I reset the position on each bounce to the position that it was at before it hit the ground, I think it might also be stable when it comes to a rest in a way that wasn't possible when I showed you in Unity earlier. Let's see if this works or not. So what I'm going to do is introduce a coefficient of restitution. I'm going to do it in a little more formal way than just hack it, which is what you normally do. I'm going to actually use a value e for the coefficient of restitution. Usually it's epsilon. The Greek letter epsilon is used, but this e is going to be, say, 0.5, which then means I want to have a bounce of a half. And so how does that work? Oh, you just multiply it by e. So why did I do that? It was a formula, 1 minus... Oh, that's for a different approach. Sorry, I was getting confused there with the rigid body mechanics stuff. So, sorry, I'm making this unnecessarily complicated. I'm going to just do this, minus 0.5f. So basically, I multiply it by minus a half. So this will halve the velocity on every bounce. Let's see how this works. Halve the velocity on each bounce. Is that a thing of beauty or what? I want to point out that we are actually only still a few lines of code here. And I'm going to try 90%. Let's try the 90%. That looks good to me. Let's look at it in 2D. Beautiful, isn't it? Really satisfying. Boom. Right on. No problem. Stable. Solid as a rock. More stronger and stabler than anyone who goes around saying strong and stable. This is great. Interesting when you watch it that it doesn't hit the ground. Look at that. It doesn't hit the ground. Well, of course it doesn't hit the ground. Because basically what's happening is the next step would have taken it into the ground and then it pops it back up. And you can see exactly what I said. It looks like it's hitting or bouncing off varying height levels. But, you know, if you really want to make it totally perfect, I even showed you last time that you can't, because if the bounce happens in between two frames, the ball will never actually hit the ground. Only hit the ground, theoretically, in between the two frames. So as Grumpy Dev pointed out, the AT squared thing, what you can do is you can use the 1/2 AT squared plus V0T plus P0 formula, you know, the formula of a parabola, to do the math to figure out exactly the intersection in the time where it hits the ground. But this is the thing, none of this is really necessary. I mean, this is literally something you could do on 8-bit computers, you know, because it's so few. You could do it, obviously I used to write, well, you could even in BASIC you could do it, you know, something like that. Boom, 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 boom. It looks quite smooth. Even though it's also the frame rate is not, you know, the fixed update and the render updates are not in sync, you know, not in perfect sync. It still looks pretty smooth. And it's not moving anywhere, because of course what happens in the end is as it rests on the surface, it's going to be taken under the surface um, by by velocity from the gravity, and as soon as it's under, it's put back to where it was, and in fact it converges because that amount that it has to push it up in order to pop it above the ground again gets smaller and smaller over time until eventually it tends to zero and you have the perfect stability. There isn't any movement there at all. So okay, so where did we go from here? Because that was one part, which was dealing with the thing. But what will be quite fun at this point, I think, is to look at, because this is one-dimensional gravity, I think it would be quite fun to look at two-dimensional gravity, or maybe I don't have time really to deal with that. So I'm wondering, what can I do now? I think I could just play with it really. So how about we put in the bouncing of the, put in some motion, so then it'll sort of, there we go. No, there he is, bouncing off. I'll make a golf game. Of course, there's no friction. Air friction. Oh yeah, air friction. And wind, just like how I added wind, didn't I? In kickoff. Well, how did I do that? On an 8-bit computer. 16-bit computer, but could do it in an 8-bit computer as well. Alright, first thing I'm going to do is, I want to do is just put in some boundaries here. Is it 1, 2, 3, 5? Public float boundary equal 5. I've got a 5-meter boundary, and I'm going to make it bounce around inside this so it doesn't go outside that area. So for that, this is all just such standard stuff. You go if the position in X is less than boundary, and I follow the same principle. Oh, we already have the previous position, so yeah, that's right. If it's less than boundary or position.x is actually less than boundary minus collision height, which is half the radius of the ball, or position x is greater than, no, minus boundary plus collision height, or position x is greater than boundary minus collision height. Then I hit the X wall, and I do a similar thing to this, where I reverse the X. Coefficient of restitution, I'm just going to have so continue bouncing. So I'm just going to do that for now. So that would hopefully keep it inside. Oh, didn't save it. Oh, what do we have now? Oh, pure blick. Oh, the X is that didn't work very well. So let's have a look. Before I do all of that, I have saved the previous position. No, X. There we go. I don't think there's another bug in that. I'm just going to copy this out. Copy paste error. We do the same with the Z. She'll bounce around inside the box. But it is now, indeed, bouncing around inside a box. And I'll view it from above just to make sure it's bouncing correctly. The perspective can make it look odd sometimes. Yeah. Hong anybody? And of course the y-axis is treated as completely independent of the other axes. So as I'm looking down, using a isometric view, you can't actually see it's bouncing apart from the shadow. So, where did I put my glasses? It's always a bit cold. Oh well, there they are. Well, there is a pair, they will do. Okay, so I'm going to just reduce the height of this thing a bit. Very nice. And that'll just carry on bouncing forever. It's not going to reduce any or lose any energy even horizontally because I followed the same pattern, although frankly there's no gravity going sideways. Of course we could always make gravity go sideways. So this is no longer vertical gravity. And you can just go crazy with this. It's kind of fun. And the thing is, it's very. Hey, Pete, how you doing? Good to see you, Pete. The thing is that this is very stable, and this is an important point. We've got stability down here. You know, to use that American euphemism. I mean, it doesn't matter how crazy I get with gravity. Oh, as long as I make sure that gravity's negative, it's flown off. 20. It's now flying up into the air at an increasing rate. It's actually coming up to 100,000 kilometers, 70, 80,000, 90,000, 100,000 kilometers. Oh, and then this message comes up. Due to floating point precision limitations, it is recommended to bring world coordinates of the game object within a smaller range. That's nice of Unity to tell you this. Hey Pete, no. I cannot really complain. I am always going to moan about Unity because I moan all the time. about everything, so I'm going to moan about Unity. But I have to say that Unity has provided me with two and a half years of employment, plus four and a half years of employment. So I have to say, is that, and in the current climate, Unity is great. I don't anticipate getting hired at Unity anytime soon, but anyway, so I wanted to do, what did I want to do? I wanted to show you, there's a little in joke there. So yeah, but these things, they do, it does improve. Unity has got better. I mean, it hardly ever crashes on me these days, except today when it crashed 4 times. But I didn't do anything different to usual, so I don't know. Maybe it's just my PC is a bit grumpy. I don't know. Click your Desmos. Yes, I knew. Thank you, Mycon. There was something whizzing around. I was going, you've forgotten something, Dino. Right, let's have a look at Mycon's Desmos. Or is it Desmost? Desmos with most. I'm going to hit play. Before I hit play, can I see if I can figure out what it's going to do? Okay, so you're going to plot t cos t. So you're taking the amplitude of a cosine, where the amplitude increases at the same rate as the cosine, and it's probably in radians. So this is spiral. So this is going. This is a kind of spiral value. Well, not spiral, but it's like it's an increase. It's a sine wave, a cosine wave that is increasing over time, and that is going to be plot. That's the x-axis. So the x-axis is going to be doing like that. Meanwhile, the y-axis is the same thing plotted with a sine. So it's going to be 90 degrees out of phase. So it's going to be like a circle, but it's an absolute. I think it's going. I think I can't work out exactly, but I'm going to see now. Let's see. Oh, of course. Something to show that student, perhaps. No, that really it doesn't. That is not how things bounce. Ah, that's cute. I like it. Kind of crazy. Like it. Yeah. Anyway, nice stuff. It's playing Pong. It's going to come against itself. Yeah. So, yes, air friction. Air friction. I'm going to get to air friction. You say it's all very well and good, Dino, but what if you want to add air friction? So, okay. Some things about air friction. First of all, air friction is going to take energy away from the system, so the stability thing is not going to be possible. If we add air friction, it's going to slow down. Tough. But that does mean that it should help it be stable. So I think the only thing there is to do is to implement the velocity change due to air friction. It's as simple as, are you ready? Should we add an air friction? We could drag. Oh dear, it's like drag. Okay, see if I can do this. I mean, it's going to be a bit tough if I can do this in the next 10 minutes. I mean, you know, it's just like, I don't know. I don't know if I can do it, but give it a go. All right, so I have to take the velocity and multiply by the drag. There you go. And now we have air friction. So because what's in it? Why? Okay, it's a form of air friction. In this case, it's where the drag is proportional to velocity, not velocity squared. But for a lot of cases, that's fine. For small velocities, it's almost the same. So it really doesn't matter. Also, it's possible if you use that as opposed to velocity squared, you can actually solve the equations of motion, which is what I did in Kickoff Revival. But having said all of that, I don't think you can for velocity squared. But having said all that, all that you do is we add to the if drag is zero, then this doesn't do anything. And if drag is 1, it subtracts velocity from the velocity. So it's actually how much of the velocity you want to have per frame. So that's the only thing I need to think about there, because I don't need to check the units. I think we should probably do time fixed delta time here as well. No. Okay, I'm a little dubious as to the units. That's the only thing. So this drag is a value between 0 and 1, and what it actually means is 1 is comes to a complete stop, and 0 means there is no drag. But the actual units I'm not going to worry about right now because I don't have time. So yeah, maybe the units were a little, but anyway, let's try it. So, why can't I didn't I put public drag? Oh, wait a minute, I have an error. Why is this a public, yeah, I've got typing. Public float drag, there you go. So this is working as normal. Now I'm going to put a drag in. I'm going to 0. Because it's per frame. It needs to be quite small. As you can see, I now have drag. I'm going to make it 10 times bigger. And then 10 times bigger, 0.1. So the idea with drag is that an object that is moving, the faster the object is moving through the air, the more the air pushes back. So the force gets bigger. It's really quite simple. You can see it there. It's quite clear. It looks like it's in a fluid here. A bit high viscosity. It reaches a terminal velocity quite easily. If I make this 0.01, you can see how it changed the shape of the curve. Still not enough to really slow down the bounce that much. Yeah, exactly. So if you're doing if you're doing something like asteroids flow, and you want the ship to slow down when you stop the thruster, you can just do this, and it's not even a line of code; it's an expression in there. I think I'm going to try this with the multiplied by time fixed delta time. That's made the drag a lot less. And now maybe if I try 1, no, that looks right. Let's try 0.5. So the last thing is, this is obviously something I did in kickoff as well, because kickoff had air friction. And that was important because otherwise you wouldn't be able to have. You see, what will happen if you don't have air friction is that in order to kick the ball hard enough, or to get the impression of the speed of the ball when it's kicked as being high, right? If you don't have air friction, the ball will just end up outside the whole field. Kick the ball up into the air and it just flies off and whatever. If you put air friction in, it has the advantage that you can have the ball kicked and get a sense of speed, but it still gets contained within the environment. Hey Zagu, how you doing? Welcome. So the thing was that when I was developing Kickoff, which would have been a few years after I figured out this kind of stuff on the BBC Micro, right? And no floating point, had to do it all in fixed point, and yeah, it was important to be efficient and all of that. And I basically used the same techniques as this to do the fundamental ball thing, but in assembly. I remember thinking, oh, well, when I calculate the drag, what I could do is introduce an offset. That is the velocity. I'm just using the velocity right now to calculate the drag. But what if I have another term that I add to that velocity? That is, I pretend the velocity is different, or rather I create an offset with velocity. And when you create an offset with velocity, what you've done is you create wind. So I'm going to finish this stream off by showing you how to implement wind on your ball, which is cool. And so I use that mechanic in the game, and that was part of what Kickoff was about. So I don't know if it was the first football game that ever introduced wind. May well have been. So right, what we're going to do is vector 3, public vector 3 wind. And what we do is we go here and we say velocity minus wind. And that's it. Now we have wind. Because what basically it's doing is it's using the air friction to generate the wind. So let's try a wind in the Z direction of, say, and it's in meters per second, so it would be like, I don't know, 5 meters per second wind. Here we go. It's not the same as gravity. It's very... Hey, Zagu! Thank you so much. Zagu is my only subscriber. That reminds me, I need to go and see if I can get my money at some point. I don't think I've ever taken it. You have to wait until it reaches some kind of, awesome, big enough figure so that you can take the money out. Something that is achievable with a lot of hard work and a lot of time streaming. Not too far off that it would be just impossible. Like maybe, I don't know, £50 or something. I've got to check. I've got to check. I've got to check. I'm not going to get a check. Nobody uses check. It has to reach $100. Thank you. So, watch this space. Meanwhile, back at the old ranch, we have wind, and as I was saying, wind is different to gravity. You might think that wind and gravity look similar here, but they're not, because gravity would just be a continual acceleration. Gravity, yeah, keep at it, Zaku, otherwise I'll never get anything. If we're still here, if civilization is still here in 40 months. So, yes, what I was saying is that gravity will cause an acceleration continuously, but with air friction, it just accelerates less and less until eventually it matches the speed. So when the ball is traveling at the same speed as the wind, then the wind no longer it accelerates. And you can see that here, this becomes 0. Yeah. I think you're right. It does look like wind. We can make a vertical wind. I can go and sort of like, I wonder what happened there. If I make an upward draft of 10 meters per second. If I make it big enough, it should take off. Oh, there it goes. Think of all the game mechanics that you could experiment with here. Like a balloon mechanic. A kite flying game. 3D Super Breakout. Look at all these ideas. You're going to sit there now and go, oh, I've got so many ideas for games. And guess why? Why? Because you did the math. Instead of just wheeling out the same old cookie cutter stuff out of Unity without thinking about what you're doing. So I hope you found that useful and maybe inspires you to delve behind things. Don't just sort of take the stuff that's delivered to you and just think that that's all there is, or that you have to do it that way, or that any thing that you find on Stack Overflow or any tutorial or anything like that is going to really give you what you really need. What you really need you will find by experimenting. So have the courage to go and do that experimenting, and then the whole world can start opening up. So take care, everybody. The next scheduled stream will be this Friday. At the moment, I'm doing 2 scheduled streams a week. There's this one on a Monday, and on a Friday I do some random jazz. I will hopefully be doing some more. And the other thing as well is there is now a radio station. So I'm building a radio station. So I'm just going to post. That's actually radion.co.uk or .com or whatever. And if anybody wants to contribute to the radio station by doing a show, DJ or whatever, there is a form on there, so you can just send your ideas and so on. Can you actually stream your radio on Twitch? I could, I need to check the license. That's actually could be interesting. I don't know that I can, actually, but you can. So I think the answer to that one is that when it's running, is there potential security risk ahead from your? Okay, it's probably because I need to. How weird! I don't get that. There is. I don't think I've got a certificate. Anyway, I will look into it. Nobody else has reported that yet, but it is actually just that here. This is the site. It's safe. Radio Radion. This is it. It doesn't do anything. You press the button, it plays the radio. I don't think it's running right now. No, it's not. It's not operating at this moment because I'm working on it. But anyway, I will look into that. Thanks for that. So a way that could work that would be legal if I was to rebroadcast it from here, and there was any commercial music on it, as just normal music on it, then I'd be breaking the license, I guess. If it's my own stuff, that would be fine. But I do have a PRS and PPL. Okay, it's just HTTP. All right. I will. Yeah, it's a work in progress. But yeah. So for what we could do, if I've got, because I've got a PRS and PPL license for it, which means I can play music on it, like anybody's music. And so what we could do is, or you could do, is put it on yourself while watching the stream, and then I can have it on too, if that makes any sense to me. Anyway, I'm off now. Take care, everybody, and yeah, keep safe and keep your spirits up. And I'll see you again soon. Take care, everyone. Good night.